Roughly half of all missions sent to Mars have failed. The environment between Earth and the red planet is characterized by extreme cold and radiation, leaving virtually no margin for error. To manage this risk, space agencies have historically relied on incremental steps. Missions typically progress over decades, starting with flybys, moving to orbiters, and only then attempting stationary landers or mobile rovers. China's Tianwen-1 mission bypassed this traditional timeline. Instead of individual steps, the CNSA combined these three architectures, an orbiter, a lander, and a rover, into a single payload launch. This single attempt transformed the CNSA's Mars presence, moving from zero to a fully synchronized orbiting, landing, and roving operation in one journey. Landing the Zhurong rover required an autonomous sequence of aerodynamic deceleration and retropropulsion to reach the southern region of Utopia Planitia. This 9-minute window is the most dangerous phase of any surface mission. Once active, Zhurong utilized ground-penetrating radar to look beneath the Martian soil. The data revealed layered subsurface structures, which suggest that this area was shaped by episodic water activity in the planet's ancient history. While Zhurong can identify these habitable environments, rovers have limitations. To definitively search for biomarkers or fossils, scientists need the precision of Earth-bound laboratories, equipment that is far too heavy and complex to launch to another planet. Returning physical samples is the only method to verify the presence of ancient life with absolute certainty. To get those answers, the mission must move from exploration to retrieval. The follow-up mission, Tianwen-3, is built around a 13-stage flight plan. It requires the CMSA to execute a surface launch and an autonomous orbital rendezvous millions of miles from Earth, a sequence of maneuvers that has never been fully realized by any space agency. Because of the weight of the return hardware, the mission uses a dual-launch architecture. 2 heavy-lift Long March 5 rockets are required to deliver the full stack of orbiters, landers, and ascent vehicles to Mars. After landing, the hardware will deploy a system of drills and scoops. The goal is to extract and seal at least 500 grams of Martian rock and soil for the journey home. As a mission searching for life, Tianwen-3 must adhere to Category 4B planetary protection standards. Every surface of the lander must be sterilized to ensure the total bioburden density remains below 300 spores per square meter. This sterilization is essential for both forward and backward protection. It prevents Earth microbes from contaminating Mars, while ensuring the Earth remains shielded from any potential exobiological materials when the samples return. The most critical engineering hurdle occurs once the samples are packed. A small rocket, the Mars Ascent Vehicle, must ignite its engines and launch directly from the Martian surface. This vehicle must remain functional after months in the extreme cold of the Martian environment. This poses a major challenge for propellant reliability, as the fuel must be ready to fire under temperatures far below freezing. Once in orbit, the ascent vehicle must coordinate with the waiting orbiter. Because a radio signal takes 20 minutes to reach Earth, this docking maneuver is performed entirely by autonomous onboard systems. After aligning in a 350-kilometer orbit, the sample canister is robotically transferred from the ascent vehicle into the Earth return module. This autonomous handoff is the mission's primary technical bottleneck. Without real-time control from Earth, the success of the entire retrieval rests on the precision of these robotic systems. After a 7-month journey back to Earth, the return module will enter the atmosphere at high velocity. It will perform a skip re-entry, effectively bouncing off the upper atmosphere to bleed off speed before its final descent. Once the capsule lands in Inner Mongolia, it will be transported to a high-security Mars laboratory. This facility is designed with ultra-clean biosafety zones to maintain total isolation. The samples will undergo a multi-stage process of sterilization and unsealing. This allows scientists to conduct a biological risk assessment before the soil is processed for analysis. The opening of this canister represents the end of a 1,000,000-mile journey. These 500 grams of material could provide the first physical evidence of life beyond Earth. Tianwen-3 is a central component of the Planetary Exploration of China program. The logistics and docking maneuvers developed here are the same capabilities needed for upcoming missions to Jupiter and Uranus. To expand these efforts, China is developing the Long March 9. This super heavy lift rocket is designed to be the primary workhorse for deep space exploration in the 2030s. The Long March 9 is projected to deliver 35 tons of payload to a Mars transfer orbit. This capacity allows for more than just simple sample returns. It provides the mass required for large-scale robotic outposts and early human missions. The 1,900 meters traveled by Zhurong and the 13 stages of Tianwen-Pri are milestones in a multi-decadal plan. They are the practical steps in a strategy to establish China as a world-class space power.